Okay, next important theorem is Fermat-Little theorem. It says if p is prime and a is any positive integer with that p is not the divisor of a, or a is not a multiple of p, then a to the p minus 1 is congruent to 1 modulo p. And this is very useful fact. Okay, let's prove it. Let's choose p minus 1 integers, which is multiple of a's. So it says a, 2a, 3a, up to p minus 1a. Then none of these integers are divisible by p because we already assuming that p is not a divisor of a. So these are not, a's are not multiple of p. And if p is not the divisor of any integer j which is between 1 and p minus 1, because p is a prime number and it shouldn't be a divisor of any integer less than itself, right? So that's clear. So any number which is used to get these p minus 1 integers is a multiple of p. So by theorem 33, all these numbers not divisible by p, and no two of these integers are congruent by modulo p because of theorem 33. Okay, by that please check it. So it's clear they are all relative prime with p, and the brief proof in 33 to show that is like this, right? So if you just choose assuming any of these two numbers like ja and ka are congruent modulo p and j are not same as k, then they should be same congruency, because a is relative prime with p and it contradicts with that fact. So if you choose j, then k must be a certain number greater than p, right? So it should be in there. So they should be all relative kind of prime for modulo p, or we can say there is no congruent numbers in there. And because of that, the least positive residue for these numbers should be 1 through p minus 1, because p is prime number and there is no congruency between any two numbers in here, and same thing here. Okay, so we found that one. So the product of these sets of numbers and that set of numbers must be congruent to each other for modulo p, because there must be a certain integer has same remainder like a has for modulo p, and same thing for the others, and like that, right? So all the multiplication is going to be congruent to the multiplication of these integers. Then from the left hand side there are p minus 1a's, right? Because 1a, 2a, 3a up to p minus 1a. So a is multiplied by p minus 1. So we can simply put a to the p minus 1, and the remaining part is 1 times 2 times 3 times up to p minus 1. So it should be p minus 1 factorial. The right hand side is p minus 1 factorial, and we already checked p is not the divisor of p minus 1 factorial, right? So greatest common divisor of p minus 1 factorial with p is just 1, so we can cancel out these two numbers. So from theorem 28 or corollary 29 more directly, we can just cancel out these two numbers from both sides, and the result is a to the p minus 1 is congruent to 1 modulo p.